Good morning. Good morning. This is Suraj Singh speaking from Bharat, India. On this day, April 27th, 2021, Tuesday, regarding live cast of quality issues in engineering and general life. Title being Civil Field Engineering Designs, Construction Methods, Contracts, EPC, AnnexSL, Organizations, Communication, Coordination, Quantity, Quality, and why should we be behind quality all time? These are various issues which are of course applicable in life and particularly in construction life. Construction is base of our world, construction is base of our India, Bharat, and construction is base of progress of life. If there is no construction, there can be nothing, we know that. Without construction, nothing can move, and without quality, nothing can move. That is fact of life. Without role of engineers and without role of engineering, nothing can move. That is also very much important. There is no dearth of engineers in our country, Bharat, India. There is no dearth of people who are professionals, intellectuals. There is no dearth of willing, but it's not happening, unfortunately. Now you can see I just take a few minutes on COVID-19 issue, which is very much of concern for whole world. Our nation has been passing through very supercritical phase, though it's not supercritical, that has to come yet. But I can say supercritical may start soon. It's you can say least but supercritical means supercritical has yet to start the threshold of supercritical phase. Every day around 3.5 lakhs to maybe it's government figure. I can't oppose it, but probably it is at least 5 to 6 lakhs per day. Cases are coming in, positive cases. According to reports, this is 3.5 lakhs per day. Yesterday case was, but I presume that is unofficial because so many people are not being tested. So we can say 500 to 600,000 patients virtually must be detected every day. Out of those tested, 14 to 15, 16 lakhs per day. Yesterday report was 14 lakhs people were tested on you can say Sunday, out of which 25%, that is 3.5 lakhs were declared positive. 25% figure is very big, very high. It is 25, it was 20, it was 20 something, it's 19, it's 18. Because for last 1 week, it has been rising steeply. If this keeps on rising, it shall be a very difficult period for our country as well as for whole world. Difficult in the sense to handle 25% population, which may include 30% also. Let's assume figure of 25% or 20% itself. If we take 25% people means about 35%, 35 crores or 350 million people maybe have been contracting COVID-19, or if you take 20%, 1/5 of that, means say 25 crores or 250 million people. So you can say 250 million to 350 million people have been contracting COVID-19, which is very important figure, very dangerous figure. You can say whole Europe is 55 crores or 550 million. So you can say about 50% of Europe is available here in our country contracting COVID-19. Horrible figure, and this is horrible in the sense that world watches us, not because we are efficient or we are giving news or we have done something very miraculous. It's because this adverse state, this difficult state of COVID-19 shall impact whole world. Second largest population wise nation, Bharat, India, is out of control of COVID-19. That is a fact of life. Whole world started, it was March 2020 when formal declaration was recorded about COVID-19 commencement and lockdown was declared, imposed. that time. People took it too lightly because of political reasons or because of some other reasons. Well, it is foolishness. It is foolishness to refer to politics when health is a question, safety of people is a question. Why should we think of politics in this case? It should not, there's no value of politics in this because people's lives being at stake. It is duty of every citizen to take care of others and to take care of nation. We can't exclusively depend on politicians because evidently politicians have failed, particularly those in power. They have done nothing that was required to be done, that was to be done, but they have not done anything, unfortunately. It's now 13 months or 12 months have crossed. It's a very big period, very large period. 12 months, projects can be completed in 12 months. And it is really shameful that we have failed in testing our population. Not even 25% people have been tested during this 1 year period. 21% or something it is, 22 maybe, real figures. Really, it raises a question itself. Where are we? What we are doing? Have we been sleeping? Are we sleeping society or government sleeping? Or people are sleeping, or world is sleeping? World never questions us. Why? WHO never questions us. Why? If we can't test our people in 1 year period, means we have to, just 1/4 people have been, or 1/5 people have been tested and 3/4 are sitting without test. They are not even aware of what's happening to their health. What sort of organization of a nation it is, really? I have to abuse myself. I have to question myself. Government must question itself. Are they really governing? They don't even, resources to test people. This is a big question mark. We can't do tests. How shall we know that this person is a patient? 80% or 75% people remaining untested. It's a great question. Who shall answer this? There is no one to answer in government, no one. Believe me, they are least bothered. They are interested in elections, they are interested in politics, they are interested in something else, which has nothing to do in this talk. I'm really sorry to say. Our government is least bothered about health of people, and people themselves are least bothered about their health. Just thinking there is no COVID, just thinking taking everything lightly is called nonsense. People's minds have been washed. Government once declared 2 months back, oh, we have won over, we got victory over COVID-19. Such a foolish government we have. It's foolish, yes. We can say foolish is not abusive of word. How can you declare, on what basis could you declare Corona has gone? How did you see it had come? How can you say it has gone? And still they are saying we will win over it. How can you win over your enemy whom we don't know? These foolish fake statements, mainly meaningless statement. You do your work, that's only answer. Prepare yourself. You must have prepared by now. 1 year you're lost. Now you're talking of I will do this and I will do that. 11th hour you will do that. It's a time to die, time to sink, and you will say, I'll save you. How can you think so? Only mindless person can talk like this. Mindless counsel can talk like this. People know this. You have not done anything. You have risked their lives. Many parts of country are under lockdown. Now lockdown shall not serve its purpose also now at this moment. Because purpose of lockdown is gone. Virus has spread like anything. It's uniformly spread over the world. It's like air itself now. Virus is like air. It's like sun. It's been everywhere. Just now I read news in Indian Express that mask must be used by everyone, even you are at home. Yes, that's true. Why do you think at home it shall not impact on you and it shall impact on you on road? How can you, on what basis can you say? I'm really sorry to say that. We are a knowledge society without knowledge. Really speaking, we call ourselves knowledge society. We are knowledge society without knowledge. We are experience society without experience. We are carefree society. We are careless society. In fact, we are only showcase society. Bharat, India, is a showcase country. We only show ourselves, see how many people we have, how many engineers we have, how many doctors we have. Doctors have been doing their job, but they are not supported by equipment, oxygen, bed, ventilator. Whose job is this? All these questions would arise. Rallies in elections, crowds in Kumbh, and so many other elections, as if life of nation is elections. Our government is hungry to get votes at cost of people's lives. Great that Madras High Court raised a question to prosecute election commissioner. It's a good one. That bloody person, election commission, must be prosecuted because that person is no more election commission. That person is the part of BJP party. It's nonsense. You were paid for your position not to be a spoon of BJP, but he became a spoon of BJP. He did what Modi wanted him to do. Is he living for Modi? Are we living for Modi? Modi is just a person as Prime Minister of this country and not honor of this country. We can't leave everything to Modi. Modi has failed drastically. He has drastically failed. What is failure otherwise? You can't control anything. All governments of states have failed. How can you say your governments and you can't do anything in time? Ultimately speaking, when governments fail, people fail. It's governments that withdraw people from being serious. It's governments. Well, it's too late now. Officially 3.5 lakhs per day cases are being declared, which may be 5 lakhs, 6 lakhs probably. Deaths they are saying 2,000 something or 3,000 something per day. I say maybe 5,000, maybe 8,000, maybe 10,000 per day, as cremation ground scenes clearly speak. There is no seriousness in our people. It's very, very unfortunate. We were never serious, and even now we are not serious. You go and see what's happening. People are not bothered. So quality of life in our people have gone. There was no quality before, and there is now substandard quality. There is no qualityless society we have. Still we have been sleeping. Still. 25% contracts of COVID-19 every day. We are sleeping. Who can awaken us? Because we are more in population, abundant population in this country. We don't care for human being. Okay, no problem. They think 130 crore people are there. If 30 crore die, what's the problem? Yes, they think that. If 50 crores die, what problem? You are right. That could be imagination. That could be hypothetication. Oh, no problem. Out of 130 crore, if half die, what's the problem? No problem. No problem at all. Until politicians' family die, until politicians' families die, there's no problem. When their family die, there is always a problem. Sorry to say, a politician's foolishness country. Idiots are politicians in this country, and super idiot is public, because public elects such useless people, useless candidates, useless politicians. I should not go to that extent, but time is telling you how to think of that. We have to bring back quality to individual life, quality to society, quality to works, quality to everywhere. Quality everywhere. That's, I say, my title is Quality Everywhere. And this is a part which I said, COVID-19 is a part of bringing back quality, reinstating quality that we have lost. Until we get public into quality system, we can't change what's quality. Everybody has to feel, has to act as a responsible citizen. And that's what responsible citizen's quality is. If I am not a responsible citizen, I'm not expected to be a responsible professional. I'm not expected to be a responsible self-mover. I won't think of quality, I won't think of making money only. Is making money only in life? Those who are realize what is difference they have, they are just enjoying money, nothing else. There are many people in our country who claim themselves richest in the world. What's the use of their being rich? They are abusing power. abusing power based on poor people. If we don't have workers, if we don't have factories, if we don't have products, how can they be rich? They are making money out of money, and this can't be called quality system. Money of nation is for people of that country, it's not for few. If you think it's for few, it's called robbery. Nobody can earn money like that. No one. I challenge. Come on, do work in field, work on labor and get this money. I'll see how you get this money. You are making money based on money. You are robbing national resources, and workers are national resources, systems are national resources. Everything is cheap and you enjoy that. You have used those people who work hard for you, and then you say, I am richest. Go to England, go to America and work like this. You shall know what is your value. Don't claim your riches. Yes, you are privileged. God, due to God's blessings, you are born in such a family which is having good background, financial background, and because of that you have come up. You have not come up by your hard work, like workers, like laborers, those who work in sun, in rain. They get money. You are not working like farming professionals who work day and night throughout day. Do something. What you are doing? Flying? Helicopter? Big bungalows? High rises? You are enjoying life? What is that? You are abusing poor. You are chanting, oh poor, you are nothing, I am everything. Remember, life is not fixed. Quality is fixed. Next moment what happens? Nobody knows. Maybe I am speaking now, next moment I go. Nobody knows. We have to think of that. Quality everywhere can only be when mind changes, mindset changes. But our minds are not changing, unfortunately, because we are not sincere. None of us is sincere. Maybe hardly 0.5 people sincere, but what values 0.5? 0.5? Nothing. So systems quality is to be generated, and that should be by individuals. If individuals don't have quality, systems quality cannot be created. And of course, we expect element quality or product quality and others remaining qualities, which can be only achieved if individuals are sincere, individuals are quality abiders, and system quality works. All this is very important point. We say we are designers. Design of everything. Yes, design of everything in life. You can do design without thinking. You can do everything without thinking. You can do designs with thinking also. But thinking or no thinking, you design. You don't care for what shall happen to quality. Maybe your design very good, but implementation is very bad. Or maybe your designs are just as because you are not quality person, your design may not be quality based. Your designs are based on imagination, they won't work. If your designs are based on practical experience, on pragmatism, economical, everything, then it would work. All stages of design, and we say construction. If design exists, it's not worth constructible. It's not fieldable. It's not constructible. You cannot say this is a good design. If a person who implements it, who works on that design for implementation, for prosecution, if that person doesn't feel pleasure, it doesn't draw pleasure from your designs, I say that design is rubbish. Because design means it should be easily workable and not very complicated. It should be professional and it should be good in construction. But that can happen only when we think of quality design, quality implementation, quality standards of products. A totality of that is required. If construction can move only then. All activities in construction are important, from excavation to finishes. All. Excavation is also very important. Finishes being very important. Everything is important. Ultimately, people don't care about excavation because they don't value what is excavation. Excavation, when we do excavation, what does it mean? We are not to forget that. When we do excavation, we disturbed strong soil. We disturb, consolidated soil. We disturb soil that has been there for centuries, maybe millenniums. We disturb that undisturbed soil. Can you think about that? You say, oh, this is excavation, this is nothing. Yes, it is excavation. It is nothing, you can't say. How can you say it is nothing? You have disturbed something which existed for centuries and you are saying it's nothing. How it can be nothing? Excavation is very important part in construction, though this has been taken over by equipment, excavator, and it has been given least value. This is what we are saying. It's just not here all over the world. Excavation done by machine, so we don't care for the, oh, you excavate whatever you want to excavate. Because we don't value that. What I say, excavation should also be considered very important item, though it's not construction material, but it is more than construction material, because your construction materials durability, your construction products durability depends on power of soil, strength of soil, and you cannot waste soil like that. Soil is most important construction material because it supports all materials. So we have to be very clear about, don't take it for granted that soil is just soil. Yes, it is just soil because it's not bankable, it's not expensive, you are not to buy it from earth, and it's available and you can go whatever you want. So excavation is very important activity, and excavation, when you do, you have to think a lot on that. You have to think a lot on your foundation designs, which one is best one, and then all activities must be taken care of, and that can be done by certain statements that you think worth is a worth. That statement which you think is worth is very important. Otherwise you cannot say that life works. Everything is important in construction, everything is important in life. In life everything is important. Just like we wear clothes, we say shirt is very good, pant is very good, and of course we think we should have good banyan underwears, so I feel comfortable and easy all the time. Same thing is excavation, which is of course hidden from views after building is constructed. But don't forget, if that soil doesn't work properly, building or structure cannot work properly. We have to be very considerate about that. Are we considerate? That's my question. So method statement means we have to keep something, experienced one or proven activities, into certain written form, so that it can be made a reference, it can be made some document which can be referred to, and we use this document repetitively and make amendments to that all time, depending on type of project, type of activity that we do, and it must be clearly understood by each and every body and member of crew, including foreman, charge, and all those who are. Of course, it is in English and it's not easy for everyone to understand, but expression of English to their own language can be affected by those supervisors who employ those workmen, work people, and every worker should know what is being done. I'm not saying they should know what's the reason behind that. No, they should not go to that much. If they can pick up fine, they can upgrade themselves, but what should be done must be done accordingly. What is written, and what is written must be written by those people who have done that. Maybe engineer, maybe general foreman, maybe project engineer, maybe consultant, maybe whosoever is responsible for that method. Because when you write method statement, this means you think a lot about whole procedure of whatever activity is there, group of activities there, and what is right, what is wrong, what is according to specification, what doesn't come in that purview. You can't write on your own because everything is covered on the specifications. Only way is to sequence of that specification is important. Method statement is that which helps you do job properly, which tells everybody what should be done. Yes, there can be variations in that. I'm not saying that it's like a line on stone. It can be varied depending on, but that variations also must come under agreed procedures, agreed values. That's what I say. Method is very important part. In India, we don't bother about that. We say so, but we don't care about, we don't understand them. With this, I know everything. I'm a practical person. I'll come to site and tell you. A practical person should not come to site, because a person who is a practical cannot say I come to site and tell you. You can't come to site always. Your paper should tell, just like drawings speak what has to be done. Can you come to site all time and tell what you are doing? Drawings, you prepare drawing. What for you prepare drawings? What for you prepare specification? You prepare this, you design, because designs would tell you what is to be done. You can't be all time on site, or nobody can be all time on sites. So these drawings, these specifications actually speak what to do. Same way, there should be a drawing which is called a method statement. I am saying drawing, because we are drawing, we write that, which then there can be sketches, there is something else. There can be tax, there can be tabulation, everything what is there. So these should be part of method statements, and these must speak. And it's not necessary that method statement applies to other activities. It depends on if it's typical, or specific. But no problem, you can write that. And method statements can lead to quality only, because when you write method statement, you have to consider quality in it. Without quality consideration, you can't go further. So we have to be very, very specific about that. This point only we bring to our attention. So we can say we have to express in those all details, format for performance, how shall we perform this activity, what's the best way. And this is what we have elected, or we have opted for, and this is according to specifications, this is according to material available, this is according to what is best one, and this has been done in other projects as well. So we repeat here, or repetitive statement it is, or specific it is, or particular it is, and this is less time consuming. This is best one from working point of view, and we can say time, this takes less time, and time on projects is unchallengeable. Unchangeable. We can't change time which is given to us. That's maximum time, or else we have to pay extra cost on that. Now question depends. I'm saying that time and cost comes into factors. Cost cannot be varied on lump sums. You can't say no, I spend more. Budget is budget. You have to complete your project within that. And if there is additional cost or variation, it's escalation on budget, and which is not acceptable in general. Until there's a compulsion, there's an essential requirement which can't be done otherwise. And this also includes risks, means spending more money is also risk, because you impact on budget. Maybe you don't have budget, then from where shall you get that money? Or time loss is also important, because you have to save time so that your project starts into operation, and these also risk factors. So cost, risks, and reliability issue. Reliability must be achieved, and you can achieve only when everything is complete and it's functional. It's not complete just in physical world or mechanically. It performs, it functions. It doesn't function according to plans, then this means there's some defect left in your work. We have to consider reliability into a way that everything is safe, everything is workable, everything works safely, everything material is safe, product is safe, procedure was safe, and now this product again service is giving what was expected, what was anticipated, or we can say intended to be achieved, is received. There was some intention, because of this project material we should take this service from this, and if it's able to do that service, is fine, means safe service and safe serviceability. And of course, how long can it move, means it can move, let us say project was designed for 10 years or 50 years or 100 years. That performance must be there, subject to maintenance. And there are so many other areas we can say which are included in reliability itself. And also important is analysis, because everything requires to be analyzed and analyzed. Analysis are also called designs, you can say. Analysis is a form of designs, because you have to design something, then you must understand what's to be designed, how to be designed, what forces the action is there to find that one, what is the resistance, how can that, means you have to analyze each point, each input you have to analyze and make sure that this input works. If your input doesn't work, this means you can't use that material or that information into your project, and that's called analysis. Analysis, you can say, there can be many analysis procedures in one problem. Sometimes there are so many problems, but there's no need of analysis which you can do. Otherwise, there's sometimes we one analysis, one material is there, we have to analyze many times various theories and various theses and find how can we solve this, and when we solve it, it's fine, it's no more problem, that becomes solution, and many solutions come together, become synthesized answers. So we say analysis, synthesis, and thinking. And thinking is very much important. Thinking is there's no need to explain thinking. But thinking is thinking. It goes on thinking itself. Thinking creates another thinking, and that creates another thinking, and that creates another thinking. And there's a sequence of thinking all the way, and that's what solutions come out of. That's the only way. Many thinkings make some format. The formats works in a contemporary form and is called template. You use the format this template to find solutions, to enter solutions, like fill up form. The form is to fill up all information in form. So thinking based solutions you have to fill up in that contemplatory form, and that must be achieved, and that's all application of engineering application must be affected, and that's what called engineering. So engineering definition is very long in this way. This is analytical definition that I'm giving you. Analytical definition of engineering. This is all analytical definition. I'll amend later on also, but this is just at a glance what I'm thinking of and what we should do. So we can say I close this file. Now I close this file also because the chartered engineer file is closed, and I'll keep and now come to management role of engineers, which is also I'm continuing on this because management role of engineers is very important, though it can't be defined, it can't be defined in one page yet. If something is better than nothing, you can say. You may say let us see, site engineer has also to be involved in retrofitting. Yes, retrofitting, though it's new world for people, you bring back to original status. Now it is generally for seismic retrofitting, but seismic was only symbolic in this page, so it's nothing related. But let us say how to be done. How can some engineer, site engineer, involved with retrofitting activities? When I written here seismic, just forget seismic in this case. That's just retrofitting. You consider structural modifications to upgrade strength. Structural modifications to upgrade strength, ductility, and energy dissipating ability of deficient or earthquake damaged structure, whatever it is, whatever we have lost in this case, we have to regain. Just think as forces, you can say seismic or force. Now seismic strengthening is what I'm saying seismic, but you consider the ordinary process of enhancing strength of existing structures. It's called process of enhancing strength of existing structures, or bringing back to original one, to make them resistant to imposed activity, ground motion or soil failure due to imposed forces or earthquakes. So we say structure is 50 years old or 30 years old, RCC or whatever. What status of that RCC material lies now? How much it works better than original one, or it has got weakened strength in this material, or you can see due to time lapse, hysteresis has played a role on this material, which means time variance means there is a variance on stresses now, concrete or steel or whatever we used in that construction. Does it work to that time when it was original one, or it has lost its strength? And if it's lost its strength, we have to impart again same strength, or lost strength. We have to fulfill deficient strength, and how to fulfill that process we say can be called strengthening or retrofitting. Now how to identify that deficiency? Now identify various priority buildings or structures, such as whatever it is. Priority buildings means schools, hospitals, nursing homes, police stations, fire brigade centers, multi-story buildings, water reservoirs, electrical stations, essential service buildings. These I am naming according to the use of these buildings, because in emergency time, whether there is a fire breakout, there is a seismic discord, there's whatever, whenever you need support, these buildings can support society, like schools, hospitals, nursing home, etc. We have to identify which structures are going to be used in such an emergent situation. Then you can say surveys of reasonable buildings, all surveys of restorable buildings. You can say those buildings which we are going to restore, these buildings, whatever these buildings are. All surveys of restorable buildings can be done by experienced engineers and those who have been on sites. And they should do it minutely. They should conduct such inspections, such studies very minutely for purpose of making a report, producing a report to decision makers, or even if site engineer is very experienced, that person can also propose what should be done. All, all details from site observations and samples collected from sites can be reported to laboratories as well as to relevant design engineers or retrofitting engineers. It requires an extensive grasp of field knowledge. Yes, that's right. It requires an extensive grasp of field knowledge of engineering, of state of chronic materials. Chronic materials, I'm saying because these are old materials. How could these materials alter their properties in given time? That can be studied by such by such inspections, by taking out samples of these materials. Recording can be done by photographs, videographs, or by taking all measurements of locations of deteriorating areas, because there will be areas that have been deteriorated due to whatever action, due to use of building, or due to limit of metal action, or due to erosion, or you can say wear and tear. So that can be done, that can be studied very well, and records can be made. Of course, I can say hand excavations is best way. Hand excavations should be effective for purpose to collect foundation sample of old concrete. Reinforcing bar sample can also be collected from non-critical areas that require a good study of structure, either from records or from site survey. Hand excavation is best way, I can say. It doesn't disturb services, existing services. It doesn't disturb anything, no machine is required. So it says hand excavations should be effected for purpose to collect foundation sample of old structure, old concrete. Reinforcing bar sample can also be collected from known critical areas that require a good study of structure, either from records or from site survey. Engineers should have patience while working on retrofitting. Detailed report should be submitted or compiled to have an understanding about health of old building or structure. If we understand that, if we can reach a conclusion of status of building is this, or how many percent step these metals have lost, and how can this be compensated by whatever method, and that's sole purpose of this study. Levels at various heights should also be recorded to reflect major settlement. Levels, when I'm saying this is land levels or reduced levels. Levels at various heights should be recorded to reflect major settlement. Deflections of members could also be recorded if feasible, because deflections would tell status of forces, actions, loadings, and settlement levels, or whatever we get from formation. But it's difficult, it's not easy, because either there's no research or there's continuous research. If you can know levels of settlement, it's very, very important. Just like deflection, information is important. Record all applied real loads on buildings. It's also very, very important part. Record all applied real loads on buildings, either by inquiring or observing. This can be different than what have been used in designs. I mean to say, whatever loads we consider in designs, it's not necessary. Building work on that load. Those loads are coded loads. Those loads are means we have to apply that. For example, when we say I take 250 kilogram per square meter live load on this floor, but when you see practically, that uniform load is never available. Somewhere it is available, somewhere it is not available. There are some tables, some chairs, some sofas, some fridge, some other machines. So that 250 kilogram or 0.25 ton per square meter doesn't work always. This means there is a variation. This floor is not, that floor is not uniformly loaded, but we consider uniform load. That's what we do. So we can say record all applied real loads on buildings either by inquiring or observing. This can be different than what have been used in designs. Columns and beams are required to be studied with concentration. Strengthening of these members shall be very difficult. Check all deformations and deteriorations because columns and beams constitute major part of framing and up to foundations itself columns go, footings go. So columns and beams which are real members. Beams take load from slabs, beams receive or bear load from slab, and beams transfer that load to columns and then columns downwards. So columns and beams are very important structural materials, structural framing materials, and must be studied carefully. It's not simply that you are studying elementary design. You have to understand what this says. There will be minute cracks somewhere, something else due to use of building. We have to concentrate ourselves on studying such type of deformations and deteriorations. Similarly, samples and the integrity of wall material should also be recorded for making a good report. It may be proposed to add beams or extended footings in foundations for which all existing data must be collected. Means you have to add beams somewhere maybe or extend sizes of footings in foundations to keep buildings safe. And also that soil which might have been strengthened if it's sandy one or might have been if it's clay one consolidated more, which is better, which is but that consolidated might have allowed sinking also, settlement also. We have to take every point into our consideration. Can say maybe propose to add beams or extended footings in foundations for which all extra data must be collected. Additional columns or beams could also be required to be added to meet various requirements for which all necessary data should be recorded on report of retrofitting survey. Retrofitting could also demand provisions of composite sections into existing one. Careful study and understanding is required for all such cases. Retrofitting is not so easy as we think. It needs complete survey, thorough survey, depending on knowledge of a person, experience of a person, and patience of a person. Retrofitting requires great input by investigation engineer, i.e., prior to making any decision. For certain structures, it may be better to rebuild as a whole, while for some or others, retrofitting would be an economical solution. I think retrofitting is economical if it is done based on complete thinking. Jacketing it may be, or something else it may be, whatever you say, or you can say add insertion of new columns or structural steel work somewhere. That can be done. Of course, it is a very difficult job. You have to study a lot. Money has to be spent on studying, survey, and then on actions. Maybe it's not that much multiple of cost of project. So you can say retrofitting requires great input by investigation engineers prior to making whatever decisions. For certain structures, it may be better to rebuild as a whole, while for others, retrofitting would be economical. Whatever be considerations for retrofitting would be detailed methods, statements giving minute sequences shall import attention, and site engineer should include all such details with elaborations for making a clear understanding of proposal. All works would certainly impact on budget. If required, reporting can be done by many stages, inspections that may depend on size of structure. Separate individual records are suggested to be made for a proper audit. Complete audit should be worked out. Now, disaster issue. No one can control disasters, whether it is caused by earthquake or by other calamities or some other reasons. Preparedness to mitigate disaster is required. Everybody should be ready to accept responsibility. Police, army, fire, professional equipment, bridge, all these helicopters, cranes, civil engineers, NGO activities, action being government constituted to coordinate, controls and assist nation outcome. So this is normal one. You might have seen this somewhere. I'm not going to details of this. It's, I think, no need. So we know all this. Very common. You might have this information elsewhere, but you can even go through this if you wish. I can leave here some, you can say. Now, what I was talking yesterday about this engineering. Facilities. We did this, I think, yesterday. We studied this yesterday, right? We studied this yesterday on this file. I think this file, I had to open another file. Let me see which file is best one for this. Just a minute, please. Let me open my system. Here it is, what I have to see. Oh, it's in my file. My file is not here. It's somewhere else. It is in. It is here, and I think it's project design, contract award, facilities petrochemicals, engineering facilities petrochemicals. I think I had to open this general facilities, project design, contract award, facilities petrochemicals, facilities petrochemicals. Now I think this is this is general facilities petrochemicals. Let me see what is that. Let me see two also better. Let me see this also better. It will work, I think. I'll close other files. This file I close. Let's see what to do in this. I'll close this. Something else here. What's that? I don't know what's happening here. What means me? 175. It's not working. What does it mean? Maybe it is maybe as a numblock. Oh, I see. This is project design, and this is here also 175. Yes, like 175. Process commission. I think we studied this one last time. This is, it is somewhere, yes, policy decision and various facility requirements, components, and we discussed on that. LNG tank, I think we're doing on LNG tanks, which we did. Compressors, so we'll start here, LNG tanks with this file. And also project designs, contract awards. What's there? It's maybe some can say small. Also we have to study this. Chapter 2 and also maybe some more chapters. I'll open that later on. Let's move here and see what we have to do. We're talking of LNG tanks yesterday. Talk of that one. Let's see how it can be done. We talked of facilities, what facilities are, what plants are, what's requirement of these for economy, for nation. At length we discussed. Yes, it's our duty to discuss, to understand as engineers, not as politician or economist, because engineering depends on requirements. Engineering doesn't depend on what I want. It depends on requirements of society, requirements of nation. But facilities, when I talk, it doesn't mean small facilities. When I talk of facilities, this means facilities, plants, processing plant, production plant, power plant, or whatever type of treatment plant you can say, where there is huge investment of funds for public interest. Petrochemicals is very important. Economical related, word or discipline. Petrochemical means we have to link ourselves to fossil fuels. Facilities are required for national development, for international development, but those facilities should be pro-human, pro-earth, pro-skies, pro-universe. But we have not abided by that requirement. We have followed only earning requirement. The earning is never basics, it's in relation to others. Again I say, earth is very small, lithosphere is very small, but for human being this is very wealthy, this is rich, because we want to extract everything that is embedded in or that is being reproduced due to actions of nature. We don't care for that, but we, being human, have a policy to exploit it for our use, and we think that we want to move very fast and we call it development, but we don't understand what's development, what's the difference between development and sustainability. We don't understand that. We want to lead everywhere, all over, all countries want to lead others, but they don't know this lead is for nothing. It's like that if you have some, you can say you have some funds and you want to use those funds. Okay, I want to use this fund, I can't digest this. I have to invest this somewhere so that I can progress further and this fund can make more money. And sometimes it's works, sometimes it doesn't work. You invest that fund to make more money. In some cases you are successful, in some cases you are not successful. This happens. You lose money in hand, it is a result, or you gain money in hand, this is also a result. We forget that we are not everyone. Monetarily, yes, we can consider that there is progress, there is development. But is there any consideration of development? If you take out cost, say, I don't care for cost, I don't want to pay more cost, I don't pay less cost, I want to get this material first. This can be bartered, this can be whatever it is, but I want to get this material. If that's in mind, that's what the mind says, I think then money is kept aside. Money goes on one end, one side, and we say, yes, that's right. As I always say, again, example of building, which you say, people say, cost of my building has gone up so many times. I bought this building in X amount, now it is 10x in 5 years or 10 years. That's okay in terms of cost, which actually indicates devaluation of money, nothing else. Always one building was built, is working, it has fixed quantities of materials, calculated quantity of materials. They can't change. Even if you wait for 50 years or 100 years, they can't change. It's our hypothetical mind, it's our imagination that increases cost of that building, and we accept that. We don't accept that all materials which are included in that building permanently stand same. There's no enhancement on them as far as quantity of those materials is concerned. If you understand this point, then you have to think of quality system, because cost doesn't value that much. Yes, it values for purpose of transactions, it values for purpose of marketing, and you spend some money but you are getting some profit now, multi-time profit, because of time lapse. And my currency is devalued, that's why I have to pay more. That thinking cannot go away. We forget that materials that we use from nature to construct this building are same, but we are wasting those materials. That's why climate is also affected. If we use some material available in earth only to your mandatory use or your need, earth won't always stop you. Earth shall help you, universe shall help you. That's why facilities are very important from economics point of view. But we are not going in that direction, all world people. We have to keep in mind this point. We are not doing anything. Whatever is given by that power in some forms which you cannot realize what forms these are. Well, I'm not going to that hypothetical talk. Understand well. You know it well, you understand well. I'm just going to physical terminology that we have talked of and shall talk of. LNG tanks, I stressed LNG tanks yesterday, and before that I studied about plants, what plants are. LNG tanks, if I say I had some carrier projects involved. Yes, this is that. You see these tanks. These tanks are LNG tanks. 1, 2, 3 and 4 there. I was little involved with them, not all. This is LNG tank. This is platform on cupola, and if you see from ground, this is cupola here. Diameter of this tank is 80 and thickness of wall is 80, while containment real tank is inside. Is encasing only, RCC encasing, PSC encasing. That's for safety purpose. When there's damage to tank or breaks up, then oil, I'm sorry, not oil, this gas at deep minus temperature should not come out. It should liquid form. And this external, this internal tank, this external one, keep it safe. Then there's functional here, and there is, you can say, air tank like this, which is called spillage tank. And then there's a piping, etc., which I am not concerned with this now. I'm saying that LNG tanks says these components are meant to store liquefied natural gas, 80,000 cubic meter capacity each with steel tank, within the steel tank. 80,000 cubic meter capacity. 80,000 cubic meter capacity. If you find 80 meters, this is pi d square of 4. 80, 6400 and for 1600 and 1600 into 3, let us say, for example, 1600 says 80 d square 6400 or for 1600 into 3, 1600 or 3, let us say around 50 or less, and 50 meters height. You can find volume of this, and that can be later on converted to weight. It's volume actually, and this is about 50 d square 80 to 6400 and 4 6400 and 4 is 1600 348, say you can say 5000 square meter, and it's multiplied by height 50 maybe, so you will get capacity of tanks, which it says here, and in definition here, $80,000 cubic meter capacity each steel tank. Now RCC or pre-stress arrangement for cable structure for about 80 meter diameter tank with 800 mm thick wall, as we have. See, height of 50 meter was included for spillage prevention. Each tank base was allowed soil improvement, including many meters depth of granular fill or backfill in layers not more than 200 mm thick. The soil improvement below foundations. RCC raft foundation was laid on improved fill, pre-engineered formation after ensuring required design, safe bearing capacity. Top of tank was covered with a permanent formed cupola structure raised to level by compressed air pressure lifting. This cupola here, you can see this cupola here, it's spherical, like half spherical, though not exactly, but you can say it is raised up, and this was done. Raising was a big question because this was very heavy cupola and it won't come down, it will stay permanently there. So what we did, Top of tank was covered with permanent formed cupola structure, and it was fabricated on ground but later raised by using compressed air pressure. It was lifted to level by compressed air pressure lifting. Cryogenic steel was included to maintain about minus 60 degrees Celsius temperature of condensed gas. Cryogenic steel, where low temperature is required, minus temperature required, we say cryogenic steel, just like as a flight goes in, when flight is airborne, surface of flight's steel material is also cryogenic because temperature in air at that level is also same as we are talking of. Cryogenic steel was included to maintain about minus 60 degrees Celsius temperature of condensed gas. Now, concrete of circular walls was poured using quick form proprietary custom design for work in 5-meter lifts each. Five meters lift each. A cantilever operational platform was constructed on cupola. An on-site designed plumbing system was erected temporarily for curing activity. Throughout on full height of tank to cover all vertical areas for curing. Each LNG tank was provided with RCC spillage below ground tank externally. These are components of this tank, formal components. You can see also in this how it looks. I can blow up more for your reference. You can see that. This one, I'm sorry. I say yes. You can see more parts of plants also. There's no pump. You can see this is all processing plant. This Qatar gas project. Now compressors. I like to show you this also. can see that here. Compressors. Compressors are to be installed. Compressors are to be installed as part of various processing trains for ethylene production unit. Being heavy reciprocating machines to be installed in massive foundations. On massive foundations at elevated levels, tabletops would be constructed resting on massive concrete foundation. Foundation concrete for one compressor being 400 cubic meter, about 25 meters long, 12 meter wide, as well as 2 meters deep, well designed machine foundations for reciprocating vibrative equipment. This foundation carries thick columns above to support tabletop. A steel plate inserted between equipment and epoxy grout. Tabletops are constructed of thick framed slabs resting on thick columns. Planned arrangements of tabletop slabs are complicated in all respects regarding civil as well as mechanical part inserts. Such types of thick and massive elements require special type of cement, probably with high GGBS replacement, which could also be pulverized fly ash or microsilicon. Particular arrangements are worked out for curing solutions for such low heat generating cement to effect thermal curing methods utilizing no direct contact with curing water. So this is just statement. I'm trying to find this file if possible. If I can find, I think. Let me go back to folder. Let me find if I can. I think columns. General sketches. I'll find something in this regard. Compressor foundation. Yes, it is here. You can see that. You can see that here. This is foundation of compressor. which I said here. Okay, it's not showing. Go for another 10 minutes and come back. Meanwhile, you can see this, and it's important to go because my legs issue. Okay. Sorry, I delayed. You must have seen this now very well, and you must have understood also very well. So I would like to explain now what is required. We are talking about compressors, and you must have seen where compressors are available here, where these are. You must have seen that somewhere here, this is, here is portion where we'll find in this area various compressors in process zone, and it's like this. This is foundation, I'm sorry, top, tabletop. This is foundation hole. This is raft, deep raft, massive block, you can say. These are columns, thick elements, and these are frame. This is a frame, you can see. These are voids here in slab, these are voids here in this slab, these voids, and this is a framing of 12 columns here. This is what about compressor foundation, that's worth. And if you now take this as a matter of fact, compressors are to be installed as a part of various processing trains for ethylene production unit, right? Compressors are to be installed as part of various processing unit trains for ethylene production unit. Being heavy reciprocating machines, reciprocating machines to be installed on massive foundations at elevated levels. Tabletops would be constructed resting on massive concrete foundation. Foundation concrete for one compressor being 400 cubic meter, maybe 25 meters long, 12 meters wide, that is 300 square meter, 2 meters deep or less, approximately. I'm saying well-designed machine foundation for a reciprocating vibratory equipment. This foundation carries thick columns above to support tabletop. Thick columns, what does it mean? When I say thick columns, this means thick members. So there are certain thickness based elements in structures. One is called thin members, like ordinary columns, ordinary beams, ordinary slabs, ordinary footings, combined footings, ordinary rafts. Minimum thickness of this element is less than 800 mm. Minimum thickness of such elements being 800 mm or less you can say, and quantity in one element not more than 8 cubic meter, or you may say even if it's more but thickness is less, you cannot call them thick element. When I'm saying columns are thick elements, means minimum dimension is more or equal to 800 mm and member is at least 8 cubic meter, then it's called thick element. When we say 8 cubic meter means quantity of concrete, which means for that size of member, and this quantity minimum requirement, that member is different type and it releases heat higher than ordinary member if ordinary concrete is used. So we have to maintain temperature in such massive concrete or such volume of concrete, which temperature should not be as ordinary concrete temperature 5 degrees to 32 degrees Celsius. This should be up to 24 degrees Celsius, not more than that, because of low heat cement we use in such materials, which could be PFA concrete or GGBS concrete or or you can say microsilica concrete, which are all these three, PFA, GGBS and microsilica, being supplementary cementing materials, particularly in this GGBS, which replaces ordinary cement to an extent of 70%, is most efficient. PFA can be used only up to 25% replacement method, or not more than that. If you use more than that, it doesn't work. And if you say take off microsilica, which is used up to 8 or 9% only, so you can say this foundation carries thick columns above to support tabletop. Steel plate inserted between equipment and epoxy grout. When you place mount your equipment on this foundation, there is one steel plate which lies inserted between equipment and epoxy grout, or you can say top of concrete, tabletop concrete. There's one plate in, and that plate is filled with space between that plate and foundation tabletop is filled with epoxy grout, not cementitious grout, because cementitious grout is meant for stationary vessels, while epoxy grout is meant for vibratory or impactable vessels, and this compressor is of course impactable vibratory. Tabletops are constructed of thick framed slabs resting on thick columns. As I said, beam frame. Tabletops are constructed of thick framed slabs resting on thick columns, as we showed in this sketch here. You can see this is thick beam frame, and if you see, this is air. In this case, it's air, and this is air without any columns. This slab, you may call it slab or beam frame, whatever you can call it. It doesn't make much difference in calling, and you have to understand that point. Tabletops are constructed of thick frame slabs resting on thick columns. Planned arrangement of tabletop slabs are complicated in all respects regarding civil as well as mechanical inserts. Such type of thick and massive elements require special type of cement, probably with high GGBS replacement, which could also be pulverized fly ash or microsilica, as I explained before. Particular arrangements are worked out for curing solutions. Particular arrangements are worked out for curing solutions for such low heat generating cements to effect thermal curing methods utilizing no direct contact with curing water. Particular arrangements are worked out for curing solutions, curing application, you may say, for such low heat energy generating cements to effect thermal curing methods utilizing no direct contact with curing water. Cracking gas furnace. Now cracking gas furnace, also I showed to you that one. Cracking gas furnace. Let me show you once again what is that, so that you may be a little better in understanding what I have to say here. You see that this is a plant, and you can see this is cracking gas furnace. You can see this is cracking gas furnace. So what sort of foundations you may need for this, you can imagine yourself, and that's where this cracking furnace. And it's located somewhere here. You can see it's located somewhere here. This is the wash water structure here, something here. It's located somewhere here. This furnace meant for purpose of cracking gas cracking gas received from refinery as a byproduct for transmission to compressors for production of ethylene as well as propane. Ethylene as well as propane. These are tall, heavy structures, vertically oriented in group of vessels and founded on a common base. Ordinary footings, in fact, ordinary rafts. Now other structures. Other structures are included wash water structures, very common structures. Auxiliary boilers, also very common structures within processing trains. Also include various vessels such as flares to contain gases, as well as tanks for storage. Foundations for tanks are generally constructed of far-receding beam, ordinary foundations. Other structures are generally provided with independent footings, stripped using grade beams. Seawater basin, very important one, talked before also. It's very important, and you can see here it is. This is where it is, seawater basin. You can see blow up of this also. Is that seawater basin? And I'd like to show you blow up of this. Where it's gone. Yeah, it's there, This is here, seawater vessel. Let's see, I discussed before also about this, but now I am doing this again because it's a part of this talk. RCC open reservoir. RCC open reservoir meant RCC open reservoir meant to continuously collect water from sea. RCC open reservoir meant to continuously collect water from sea through 2 number 84 inches pipe. In this case only 2 number, couple of pipes, you can say 2 number 84 inches pipes store in this reservoir, supply to plant various trains requirements, and after cooling installed system used water to be disposed of from various industrial locations to this receiving basin and then further to outfall chambers. Should this water may not be reused for process unit system cooling, means after cooling water cools a number of times, then it is to be disposed of to outfall chamber or through whatever technology applies. So can say RCC open reservoir of water meant to continuously collect water from sea through supplying pipes, store in this reservoir, supply to plant various trains working requirements, and after cooling installed system use water to be disposed of from various industrial locations to this receiving basin and then further to outfall chamber. Should this water may not be ought to be used or processed. Now, it's huge voluminous open structure, huge voluminous open structure constructed of RCC base slab, provided various contraction and construction joints. During its being executed on site construction, peripheral retaining walls up to 12 meter high, not more than 9 meters length of panel, as well as covered pump houses. Unit area is So you can say it's huge voluminous open structure constructed of RCC base slab, provided various contraction and construction joints during its execution on site construction, peripheral retaining walls up to 12 meters high, not more than 9 meters length of panel, as well as covered pump house unit area and metal baffles. You can see what it says. Again I say it's huge voluminous open structure and constructed of RCC slab, provided various contraction and construction joints during its execution on site construction, peripheral retaining walls up to 12 meter high, not more than 9 meters length of panels, as well as covered pump house unit area baffles. So you can see 12 meter high, not more than 9 meter length. So 9 meters into 12 meters, 108. 108 into, let us say, 0.5. 108 into 5, which is 54 cubic meter. Say considerable quantity of concrete, considering wall 50 centimeter thick, or if it is less, I think it's not work because height is 12 meters. So 50 centimeters to justify half a meter. This means 108, 54 cubic meters in each wall. It's a big quantity. As well as covered pump house unit area and baffles. Such structures must be watertight. Yes, it should be. Such structures must be watertight effectively from all locations of water storage. Such structures must be watertight effectively from all locations of water storage portions, duly tested for water tightness, conforming to BS 8007 criteria. Concrete protection is applied for both below ground as well as above ground RCC surfaces. Testing would be little cumbersome for many days and weeks and factor to be used for computing evaporations. Losses is complicated since no pertinent standard data being available. A parallel arrangement is as a device has to be arranged to observe real evaporation loss. Concrete protection is applied for both below ground as well as above ground RCC surfaces. Testing would be little cumbersome for many days and factors to be used for computing evaporations losses is complicated since no pertinent standard data being available. A parallel arrangement as a device has to be arranged to observe real evaporation loss model, result of which could be applied to reservoir evaporation observations. Many days shall be involved from start of water filling, autonomous healing of surfaces, and then performing stage-wise applicable water tightness testing. It could amount to 2-3 weeks for testing performance, and if results being satisfactory, removal of water from reservoir is possible, or otherwise after removal of water, making repair of water leakage as recorded by an application of resin injection to epoxy repair, followed by another water tightness test for final observation of leakage. many other stationery. Let us say what other many other stationery. Actually, stationery means equipment. This is vessel. This is as well as vibratory equipments are included for processing plants for which foundations are constructed. Accordingly, either as footing, base, or combined footing, these horizontal or vertical vessels are erected on these bases connected using anchor bolts and grouting done between sitting steel plate and top of concrete. For vibratory equipment, epoxy grouting is applied, while for stationary equipment, cement based grouting is suitable. It's very common that we generally use, we fill this portion void between plate of machine or equipment and concrete top. That void is filled with grouting. This is cement based in case it is a stationary vessel or stationary machine, and it is not cement based but epoxy grouting if it is dynamic machine or vibratory machine. This is to be remembered very carefully that two grouts are used. Weak grout is cementitious grout, that is for no impact, only horizontal, only vertical forces, static forces, and in case of grouting, which is epoxy one, that is used for dynamic machines, vibratory machines, pumps, etc., etc. Keep in this mind epoxy coating. Now some chambers. These are ordinary chambers. To be very frank, you can say, let me see if I have some in this. Let me close this. Let me close some these for current one. So I have space enough for. I close this also. Then let us see if some chamber is available. I can't keep all files open. This I have to talk of. This some chambers, and this is okay. Let me go to see if I can find something about that. This is what's that? See what are we saying? Sump chamber, yes. This is some chamber. Sump chamber. Size is here, you can say about 15 meters, possibly. Wall thickness is 500, so 14.2 and 1 meter this way and that way. 15.2 into 10.2 external size, and then there is projection here 1 meter below, structural projection of base slab. So base slab thickness is 500 mm and wall is 400 mm, sorry, not 50, 500 mm. So 9200 and 800, this is 10 meters external and 15 meters external. 15 by 8 is size of this slab, tank. 15 by 10, and base slab is then at 2 meters. This 17 by 11, right? 17 by 11. It is visible here, 17 by 11. This is sharing. Okay, if you can take this way, that way I don't have to. Yes, let me see. Yes, 17 here and that's 11 here. You can see this very small sketch, and there is a freeboard also available above inlet pipe, which is 8 meters deep from floor to ceiling can say depth of this tank is 8 meters, and inlet pipe is here, which is having a 1.31 meter, 1.315 mm freeboard. So water content in this can be, this is 8 meters minus 1.315. It would be, let us say 7.5, let us suppose 7.5, I'm sorry, 6.5 meters depth. So internal size is say 9 meters by 14 meters, 126, 9 into 14, 126 square meter into 6 meters. You can say, you can find volume of this water, storable volume approximately. So that size of this sum. RCC slab, RCC walls, RCC base, inlet pipe here, inlet pipe here, outlet pipe here, and safety requirements are there, which different one now. So we can say here, these covered chambers are used for collection of water from various catchment areas and constructed of RCC underground structures, duly tested for water tightness using BS 8007 code. Concrete protection is applied for both below ground as well as above ground surfaces. Manholes, catch basins, rainwater ditches, etc. are constructed using RCC. Hundreds of manholes, catch basins and rainwater ditches must be available. Manholes are meant for sewerage lines. Oil manholes for oily discharge. Catch basins for rainwater. Catch basins for rainwater. Oily manholes for oil, and manholes are meant for sewerage. Generally, these units would be provided in large numbers for certain plants areas, making it preferable to produce by precasting on site, for which all working details shall be required. For example, I will show you here some details of manholes only. Manhole covers, not manhole covers, I am trying to show you manhole details. Where it is? Water resources, manholes, yes. This one here, I can show you detail of this so that it will be clear to you at least what I am talking of. It's important that we understand what we talk of. You can see this. Essentially, this is details of manholes that are going to be precast. Plans are available, internal elevations are available. Internal elevations because these details are required for precasting engineer in yard, where you can say pipes are to come in, and there where pipes are to come in, for example these blockouts are shown in walls. These blockouts means pipes that were inserted in here, and these are RCC walls and bases. Similar, this is plan and manual entry here. Steps at one side. This is a typical sketch, means there are so many sketches like that. For purpose of showing to you, I decided to. So generally these units will be provided in large numbers for certain plant area, making it preferable to produce by precasting on site, for which all working details for proposed yard are required to be issued to site, each and every detail. Then open ditches. I should put my fully charged off so that this can be okay. Then open ditches are constructed for discharge of storm water. Open ditches are constructed for discharge of storm water. These ditches can also be used for purpose to give way to fire water disposal during fire break out on installation. These ditches can also be used for purpose to give way to fire or water disposal during whatever fire break out on installation. This may also be used for demanded purpose of intended water line maintenance, discharge from some single loop. As it can be used for demanded purpose of intended water line maintenance, discharge from some single loop. At commencement, ditch section is considered shallow, but as it reaches moving within various catchments areas, ditch section is considerably deepened like a big city drain. Now, piping is now, let me close these files because it takes memory for nothing. So I am taking this manual off, I am taking this sketch off, and let us keep as it is now. Carbon, steel or ductile iron or fiber reinforced plastic family, that is GRP, ERP, GRE, etc., are included depending on requirement and structural adequacy to sustain various impossible stresses. A stress analysis is conducted out. Structure analysis is conducted out. So bloody hell, so कम कर सकते. Okay. Carbon, steel or ductile iron or fiber reinforced plastics family are included depending on requirement and structural adequacy to sustain various impossible stresses. Stress analysis is carried out for various loops, giving locations of various supports as well as anchoring requirement. Various types of supports are designed for varying diameter of pipes for on-ground or underground or above ground use. Fiber reinforced plastic pipes, FR. Fiber reinforced plastics pipes. Now RTRP is an abbreviation. RTRP stands for reinforced thermosetting resin pipe. Reinforced thermosetting resin pipe, a composite material consisting of a thermosetting polymer, a type of polyester, reinforced with glass, polyester reinforced with glass or other fibers that provides a strength and stiffness to a composite material. Again I say RTRP, which stands for reinforced thermosetting resin pipe, is a composite material consisting of thermosetting polymer, a type of polyester reinforced with glass or other fibers that provides strength and stiffness to a composite material. Different types of resins for manufacturing, that is GRP, GRV and GRE pipes are used. Now isophthalic resin, these are pipes called isophthalic resin, that is vinyl resin and epoxy resin. GRP, GRV and GRE. Here P stands for isophthalic resin, V stands for vinyl resin, and E stands for epoxy resin. R is common and G is common. respectively, that are selected according to required properties like chemical resistance, temperature resistance, and other mechanical properties. Resins provide thermal and chemical properties. Resin, Resins provide thermal and chemical properties such as transition, glass transition temperature, resistance to heat, chemical resistance, and etc. required for finished product. Resins provide thermal and chemical properties such as glass in transition temperature, of course, can say resins provide thermal and chemical properties such as glass transition temperature, resistance to heat, chemical resistance, etc. required for finished product. Properties of GRP pipes can be varied by changing ratio of raw materials as well as winding angle. These pipes consist of 3 layers adherent to each having different characteristics in relations to functional requirement. Then properties of GRP pipes can be varied by changing ratio of raw materials as well as winding angle. These pipes consist of 3 layers adherent to each other, each having different characteristics in relation to functional requirement. Now we say inner layer or inner liners, VL glass, resin, CSM glass, resin, structural wall, that is roving glass, resin, you can say. Then external liner, VL glass, resin. So inner is VL glass, is resin, glass, resin. Structural is in between inner and external, which is roving glass, resin, and external liner, VL glass, resin. Composition. This is very important material. You have to be a little hungry to understand such information. If you are hungry, you will certainly digest it. And if you are not hungry, I can't help it. Now, inner liner well. Inner liner. Glass. Resin is CSM glass resin. Inner liner layer is chemical resistant. Inner liner layer is chemical resistant due to being in direct contact with fluid and therefore responsible to resist chemical corrosion as well as permeability. Internal surface is particularly smooth to reduce fluid head. Inner liner layer is chemical resistant due to being in direct contact with fluid and therefore responsible for its chemical corrosion as well as permeability. Inner surface is particularly smooth to reduce fluid head loss. It's particularly smooth to reduce head loss and also opposes growth of minerals and algae. This liner, this liner has two monolithic sublayers. This is inner liner, two monolithic sublayers. Inner one is in contact with fluid is reinforced with glass wheel with resin content 90%, while outer layer, outer one, now inner surface is particularly smooth to reduce fluid pressure, fluid head loss and also opposes growth of mineral and algae. This liner has two monolithic sub-layers. Inner one which is in contact with fluid is reinforced with glass wheel with resin content 90%, while outer one reinforced with CSM glass with resin content 70% by weight. Standard liner thickness is about 0.5 to 0.5 mm standard liner. Then you can say standard liner thickness is about 0.5 to 1.5 mm. You have to read this with great patience because this is components of these walls. It's a very important one. You have to realize. So we say now. I repeat this. We'll say structural wall. What it says. Structural wall is a resin first. Roving glass is in between two layers. Glass reinforced layers guarantee mechanical resistance of whole pipe against stresses due to internal and external pressure, external loads as well as thermal loads. For GRP or GRV pipes, this layer is obtained by now we can say glass reinforced layers guarantee mechanical resistance and mechanical resistance. You can then for GRV pipes, this layer is obtained by applying on previous partly cured inner liner, continuous roving of glass wetted with resin under controlled contention. For GRV pipes, structural wall is wound directly on a wet liner. This layer can contain aggregates like silica and if allowed by specifications, while thickening depends on design conditions. can say then structure wall. I'm talking here structural wall, which is of course important point here. Again I say roving, that is structural wall between two internal inner cores, inner layer and external layer. You may say that is inner one and external, inner liner and of course inner liner and external liner. There is a structural wall which is a roving one, glass resin. So it's a roving glass resin. You know what is roving means. Glass resin. What's roving? Let us be very clear. What's roving here? I should go to technical meaning of this. Just a minute, please. What is roving? We have to understand what is roving here. It's sometimes important to understand meaning of roving. I should say technical meaning of roving. Roving. This is not staying anywhere for a long time. Not staying anywhere for a long time and moving from one place to another. एक स्थान से दूसरे स्थान तक घूमते रहने वाला, घुमक्कड़, घुमंतु, भ्रमणकारी, सैलानी, याराबार. So I spoke in different language also. It's called not staying anywhere for a long time and moving from one place to another place. This is meaning of roving, and that roving, as what we say, roving resin. Glass reinforced layer guarantee. Glass reinforced layers guarantee mechanical resistance of whole pipe against stresses. Stresses due to internal and external pressure, external loads as well as thermal loads. For GRV pipes, this layer is obtained by applying on previous partly cured inner. For GRV pipes, this layer is obtained by applying on previous partly cured inner liner. Continuous roving of glass wetted with resin under controlled tension. For GRE pipes, structure wall is wound directly on wet liner. This layer can contain aggregates like silica, sand if allowed by specifications, while thickness depends on design conditions. So what says that for what first is glass reinforced layers which guarantee mechanical resistance of whole pipe against stresses due to internal and external pressure, external loads as well as thermal loads. Now for GRP class and GRV pipes, this layer is obtained by applying on previous partly cured inner liner. Continuous roving of glass wetted with resin under controlled tension. For GRE pipes, structural wall is wound directly on a wet liner. This layer can contain aggregates like silica, sand, and if allowed by specifications, while thickness depends on design conditions. External liner, wheel resin. External liner. Top coat or external liner is an outer layer of pipe consisting of pure resin. Ultraviolet UV protectors may be added if so required to protect pipe from effects of solar exposure. In case of meeting severe exposure condition, in case of meeting severe exposure condition like aggressive soil, severe exposure conditions like aggressive soils, a very corrosive environment, this external liner can be reinforced with a surfing valve or added with filters or pigments. Fiberglass composites consist of glass. Fiberglass composites consist of glass fiber reinforcement, thermosetting resins, and additives designed and processed to meet specific functional performance criteria. Now general about this. The amount, type and orientation of glass fibers in pipe provide mechanical strength. What's amount, what's type and orientation of glass fibers in pipe provide mechanical strength. C glass, E glass and ECR. Advanced glass are used commonly depending on pipe application. Various forms of glass reinforcements are named as surface veil, chopped strand, matte CSM, chopped roving, filament roving or woven roving WR. Raw materials like catalysts, accelerators, inhibitors, aggregates and pigments are used together with resin and glass reinforcements to achieve desired properties of fiberglass product. Catalyst is an organic compound. Catalyst Okay, then we can say catalyst is an organic compound which when added to resin in presence of an accelerator determines polymerization reaction and off. Cause problem otherwise. So catalyst is an organic compound which when added to resin in presence of an accelerator determines polymerization reaction at ambient temperature. Catalyst is an organic compound which when added to resin in presence of an accelerator determines polymerization reaction at ambient temperature. Accelerator is a chemical compound. This is accelerator is a chemical compound used together with the catalyst to shorten polymerization time. Inhibitor is added to resin. Inhibitor is added to resin to reduce reactivity at ambient temperature. You can say there are two manufacturing processes: dual helical filament winding process and another being continuous winding process, Drossthal. This was about piping. Now pipe racks. Pipe racks. Pipe racks is now 73%. Pipe racks are used for required purpose of running piping from one point to other over ground levels. Running piping from one point to other over ground levels. These are generally constructed of steel structure founding on RCC footings, but RCC frames structures are also used. Several kilometer pipes are used or run over these racks supported and anchored to rack structures. These are fully accessible structures of maintenance purpose. For maintenance purpose, open steel or plastic flooring is provided on decking. Heat tracing. Heat tracing is applied on piping carrying -degree gas, which may freeze during flow and block flow within pipes. For protection of which heat is continuously maintained on piping to keep warm carried gas in condensed form. Various loops are provided on piping routes for various purposes. Pipe supports, sleepers. Pipe supports or sleepers. These are used for purpose of carrying pipes at near ground level. These are RCC units located at defined spacing. For direct support of pipes, steel structural supports are employed, remaining either connected or touching pipes by shoes or lengths at various spacing, meant for purpose of sliding also. For deciding locations of such supports and their anchorages, stress analysis is conducted, which dictates required spacing, dimensions, and pipe structural base design. For a pipe of diameter not more than 4 meter, not more than 12 meter spacing is adopted. For a pipe diameter not more than 4 meters, not more than 12 meter spacing is adopted. For other smaller diameter pipes, spacing depends on standard length of pipes. Pipes that need sliding movement at joints are provided with such a base that allows movement of pipe in direction of its run. For that purpose, PTFE, which is known as polytetrafluoroethylene bearings fixed on steel plates, duly designed to withstand imposed forces, are provided. Below pipe support shoe steel portions. A stainless steel plate is provided so that this plate slides over PTFE pads. Below pipe support shoe steel portion, a stainless steel plate is provided so that this plate slides over PTFE pads. Anchor sleepers. Big sleepers, thrust blocks, etc. are employed at various points, locations, depending on stress analysis requirement on en route pipeline. These are thick and voluminous structures requiring 1000 cubic meter RCC for an individual sleeper connecting a group of pipes. On pipe loops, various kinds of stresses from all directions are imposed upon during operations or flows, which are resisted by these sleepers. At change in direction of pipe routes as well as at T locations, etc., big sleepers or thrust blocks are provided to resist resultant forces. These sleepers are constructed of RCC massive block. We'll see another file as well. Now this is project design, contract award and miscellaneous. In this are certain abbreviations. Let us see first. These abbreviations have been used in documents. We should know them. What AG is above ground, AFC is approved for construction, AFD is approved for design, BFD block flow diagram, BFD block flow diagram. PFD is block flow diagram, CCR is central control room, CCTV is closed circuit television system, CCWS is common cooling water system, CDR is conceptual design report, COM is commissioning, CP is cathodic protection, CT is cooling tower, CW is cooling water. Receiving direct current, DCS is distributed control system. Easement, all land provided by client to be used by contractor for purpose of construction. EPIC is engineering, procurement, installation and commissioning. EPIC is engineering, procurement, installation and commissioning. ESDV is emergency shutdown valve. EWS engineering workstation. You may say also ESDV is emergency shutdown valve, EW is engineering workstation, FAT factory acceptance test, FOT is fiber optics transmission system, FEED is front end engineering design. FMEA is failure mode and effects analysis. Failure mode and effects analysis. Then FO is fiber optics, FRP is fiber reinforced plastic, generic name including GRP, GRV, GRE piping. FNG is fire and gas system. GAD is general arrangement drawing, GIS is gas insulated switchgear, GPS is geo positioning system, GRE is glass reinforced epoxy, GRP is glass reinforced polyester. Then we can say here GRP is glass reinforced polyester, GRE is, I can say GAD is general arrangement drawing, GIS gas insulated switchgear, GPS is geo positioning system, GRE is glass reinforced epoxy, GRP is glass reinforced polyester, GRE is glass reinforced vinyl ester, polyester is P, glass reinforced epoxy, GRE is glass reinforced vinyl ester. When you say GRP glass reinforced plastic, GR is glass epoxy, GRV is glass reinforced vinyl ester, GGBS is granulated glass blast furnace slag, HVAC heat ventilation and air conditioning, HMI is human machine interface, SSD is high sensitivity smoke detection. Then we go forward. See what we do. Another consideration here is we go to we go to HMI, that is human machine interface. HSSD is high sensitivity smoke detection. ICA is instrument control and automation. IDF is intermediate distribution frame. IO is input output. N tool, in tool, trademark name of Intergraph, software for instrumentation, and IST is integrated system test. ITP is inspection and test plans. IOM initial operating maintenance. LAN is local area network. LBV is line break valves. LER is local equipment room. LLCC is local lot control center. LEED is leadership in energy. Leadership in energy and environment design. MC is mechanical completion. MCC is motor control center. MDF main distribution frame. MOV is motor operated valve. MTO material takeoff. MWS is marine warranty surveyor. That is MWS, MS microsilica, and ONAF oil natural air force, on non natural oil natural, and you'll see more as we go ahead. There are so many in this. You have to understand them as well. Important point is involvement of multidisciplinary team for required design. That is important point. Process engineers, chemical engineers, reservoir engineers, mechanical engineers, electrical engineers, electronics engineers, instrumentation engineers, IT engineers, civil and structural engineers, coordinating engineers, planning engineers, quantity engineers. Then we can say process engineers, chemical engineers, reservoir engineers, mechanical engineers, electrical engineers, electronics engineers, instrumentation engineers, IT engineers, civil and structural engineers, coordination engineers, planning engineers, quantity engineers, surveying engineers, cost control engineers, etc. shall be included to formulate an overall strategy of designing proposed plant processing system, further supported by soil engineers, hydrographic engineers, geological engineers. After having proposed basic design in desk conceptualized, further feed detailed works shall be undertaken for documentation by all disciplinary teams for elaborate formation relating to various details to be used on proposed project. We have to understand all these at later stage. I'm just trying to show what we have to do, what we have to do. That's a very important part of this. Then we can say, to understand, if we go down this, we'll see what is there. Tender documents, then this is, I can see, bid evaluation, obligations to enforced by contractor, tender proposal, you can see contents on this file. Of course, very great contents on this file, you can see. So you can see what's there in this. Let me say this is there and this area. So you have to go back and see how it works. We have there, says, you can say access platform, RCC box culverts, receiving basin, flare towers, pump houses, general components for other facilities, reliability and availability. Then we have design basis, mechanical equipment, design life and experience, list of codes, specifications, etc. Then equipment covered, equipment selection, then we have centrifugal pumps, etc. and all these, some pumps, dry water pumps, instrument air compressor, dry package, we have electric overhead traveling, EOT, we have semi-portal crane, other EOT cranes, mechanical plant, bar, screen and braking mechanism, design basis, mechanical equipment, mechanical plant, stop logs, rotating drum screens, and storage tanks and emergency diesel generator sets, spare parts, shop testing, building services, electrical supply, fire suppression, cathodic protection, cooling towers, and that's what we have in this. We can say this is chapter 1, and that is, we are doing chapter 2, and let us see chapter 3 as well. I think we can, let's say chapter 3, and it is in this, not in this other one. This is fisheries on shore, chapter 4. Enjoying GGV I have not taken. I'll let me take it. I'll show you at least. What is that? Let me show you what's that. It's an important one. So we'll take print out of this and let me see how it works. It's no problem, it's coming soon. So it's okay now. This is Chapter 4. To save it. So we have said that to save it. We saved it. In this chapter 4, concrete durability, supplementary cement materials, this case, and look into that. SCMs, fly ash, all this we'll see. Blended hydroxide cement aggregates, chemical admixtures, etc., etc. Production is for concrete durability, supplementary cementing materials. Production of every ton of Portland cement. Production of every ton of Portland cement and essential constituents of concrete releases about 1 ton of carbon dioxide into atmosphere. Means weight of cement and same weight of carbon dioxide is released into atmosphere. Partial replacement of cement with SCM, that's called supplementary cementing materials, reduces greenhouse gas, that is GHG emissions proportionately, resulting in a more green concrete through reduced energy consumption, which is required to produce cement with avoidance of process emissions related to limestone calcinations. It is required to produce cement with avoidance of process emissions, that is related to limestone calcinations. Additional benefits include minimization of waste. Additional benefits include minimization of waste disposal by using such materials for landfilling with these industrial byproducts, causing lesser pressure on natural resources, such as reduction in limestone consumption used for production of cement by replacement of part of cement with SCM, while SCM are used judiciously. Improved concrete properties and durability can be achieved, also required for sustainability of available energy for future generations to come. Sustainable development demands that state-of-the-art technology should be developed in such a way that current requirements are met while preservation of energy should also be left available to be used by future generation without difficulty or causing unbalancing to natural equilibrium of energies. It's also true that yet a thorough knowledge technology requires development to understand certainly all aspects of producing durable concrete. Now this talk which I am just giving you a file is for just understanding how can we use cement in our products, in our projects, which is very important for civil engineers, particularly for those who have designs elsewhere. This is consider these points very well. So we have air files open like this, and also this project design contract awards and miscellaneous chapter 2. This is chapter 4 I discussed, this is chapter 2, and this is chapter 1. And of course applications which are talking of. It's very important for quality of the air. You should say engineering itself. It goes down like this. It's easy to say we'll get quality. It's very easy to say, to claim we got quality. Commercially to say that is okay. People say commercially, not otherwise. On televisions, advertisements will find so much useless information, useless, irrelevant information, claiming everything. This is general. But fact remains that quality is not easy to be achieved. We have to do a lot on that. That important point we should really understand and make a note of what actually we can get, what we cannot get. Quality system must be understood first. And before understanding, if people are experienced, people are pragmatic, I mean to say engineers are pragmatic, experienced, and they really want to serve nation and serve society, they should come up to talk of quality, because there is a sheer lapse of quality. Understand that. There is a sheer lapse of quality. It's no question whether they accept or they don't accept facts. But this is fact, that quality does not exist. That is a fact, which fact we can't change. We can't change that fact, that quality is not available. That point must be considered and taken care of, which we are not doing. It is unfortunate that we are not doing that. Must be done. Why it's not done is out of my philosophy, out of my, you can say, out of my controls. I don't know what's behind that. But it is not also so easy as we think it is. It's not that easy. We have to do it again and again, again and again. We have to do it, or else we can't do justice to ourselves. We can't do justice. We can't do justice with anybody. That's what we have to understand this. I still look for how to manage quality, which is really important point in every engineer's life, and we should not forget that quality is of utmost importance to everyone. It may be realized, it may not be realized, but it is. If you don't, means don't. If you don't do quality, engineering is not done. So simple. It is, a challenge. It's a challenge now. Production of quality is a challenge because non-existence cannot immediately be made existent. In fact, generally, quality does not exist. There's no evidence required for this. You buy whatever product, you buy whatever service, you won't find anything else. Nobody wants to mandate. Yeah. Now time comes when we have to control ourselves. We have to understand ourselves. We have to take ourselves into that domain where quality has to be understood very well. If you don't do that, I can say that I cannot call myself engineer if I cannot concentrate on quality system, quality production. And if I call engineer myself, in that case, I falsify myself and I falsify whole universe. Universe gave us everything. Quality, if can be achieved, means it's a big achievement because we are falling short of quality, and falling short won't work. It must be taken care of. Again and again I stress on this, I emphasize on this, that quality is very important, and if we do not understand this point, we will lose engineering ourselves. We will lose engineering ourselves in every aspect of life. We have to be considerate on that quality is not easy in this situation when people are not serious. And if people are not serious, how can you claim quality exists? It's a big point to be clear. With this I take your leave from today's talk. Thank you very much.